Hello. Today we're going to do a demo of symmetrical multiprocessing fault-tolerant VMs, or SMPFT. The setup we have today is 3 virtual ESXi hosts all running vSphere 6. In other words, we have vCenter 6.0 B version actually, and the same thing running on all 3 hosts. If I show you the 3 hosts here, you can see that we're running fault-tolerant solution already on all of the hosts. Now you may notice that right above fault tolerance there is also the option for fault tolerance legacy, and you'll notice it says unsupported. The prerequisites for the newer version of fault tolerance supporting multiple vCPUs in your VM has changed the requirements on the host itself. If you really want to support the legacy version, which is single vCPU for your VM, then you actually have additional steps to go through with your hosts and your cluster to make that happen. So today we're just going to be demoing the dual vCPU. Now with multi-processor fault tolerance, you can do, depending on your licensing, either 2, 3, or 4 virtual CPUs on your host. Obviously, to have the highest version or the highest number of virtual CPUs, you need to have Enterprise Plus. So for the rest of this demo, you'll see that we have listed on the left side in the vSphere client the 3 hosts that I'm working with. And the idea is that this VM that we're going to enable fault tolerance on is currently running on host 177, as you can see right here. You can also see here in the related objects. It currently has IP 172.16.7.32. If you'll notice over here on the left side, I've got a continuous ping running against that particular IP address. We also have down here the console to the VM, and this is the actual remote console to the VM. Let's log back in here very quickly. And I'm going to be running a video from YouTube. Now obviously it's going to be a little jumpy because I'm actually remote desktop into a terminal server, and I've got all of the console windows open for you here. So let's start by enabling fault tolerance on this particular VM. When we do this, of course we're going to get a wizard, and the wizard's going to pop up and say, where are the secondary VM disks and configuration files going to go? This is one of the changes to the current and newer version of fault tolerant capability with a virtual machine. We actually duplicate the configuration file and the VMDK on a completely separate data store now. So there's true fault tolerance not just for the running of the VM, but also the files that make up the VM as well. So I'm going to choose the same fault tolerant volume that I've pre-created for all of these. You'll notice the compatibility checks succeed. As we click next for the wizard, we're going to have to pick the host we're running on, or want the secondary VM to run on. In this case, we're running primary is going to be running on 177, so we could pick, so now when we pick our host, we should get a validation succeeds. Good. Alright. Now this does take a little while to happen. What we'll see here is that eventually we're going to get a new pane over here on the right side on the summary screen of this particular VM. It will also tell us which host the secondary VM is running on. Now, for any of you that have been running the web client for a while, you know that we do need to refresh it manually. It doesn't refresh all the time in real time. Sometimes it'll update on its own, sometimes it won't. Okay. Let's take a look and see at the cluster level. We see a high ping packet here. We should immediately have a secondary built. But obviously it takes time to get the files copied over. So let's go up to the cluster level. Fault tolerant state has changed. You notice we also have that on the VM itself here. Okay, so that means we are building the secondary. We notice down here we also have our new fault tolerant pane. Drag that up so we have it close to the other one. Now the secondary VM is starting up, and it's starting up on host 178. If I click on the hyperlink to host 178, we can go take a look at, on the Related Objects tab under Virtual Machines, the secondary VM. Now, unlike the older version that we could open up a console window to the secondary VM that was read-only. If we were to open one to this secondary VM, it would be a black screen. We can no longer view the processing that's taking place or the updates that the log files are shipping over. Okay. Now, because the technology is different, we do have more information traversing the network from the primary to the secondary VM on the other host. As a result, the newer version of fault-tolerant VMs must use, between the hosts, 10 gigabit pipe. Okay, 10 gigabit pipe. You can't use the 1 megabit that we had with the legacy version. All right, because there is more information going back and forth. There is information about the disks and what's changing on them. So that's why we need a much bigger pipe than we used to use. All right, I'm going to click Acknowledge on the selected alarm. And you'll notice now we are already in a fault-tolerant solution. We had one ping drop out there just as we finished up our secondary VM. And notice right now the log bandwidth usage is minimal, or actually not even showing up. If we refresh the screen, maybe we'll get something going on here. But eventually, that's going to show us the detail. You'll notice over here on the left we have the different colored icon, a little bit darker blue icon for the VM that is now fault-tolerant. So currently we're running on host 177. It has a relationship between both data stores right now for this primary VM because the primary is running on fault-tolerant volume, the secondary is running on shared access, and the secondary is actually currently running on host 178. So what I'm going to do down here in the console of the VM is start the video so you can watch something running in real time back here. And then what we're going to do is, since we're now running on host 177, is choose that particular VM in our other window and crash it. We're literally going to power it off to force the equivalent of a crashed host in the real world in a physical environment. Okay. Now you'll notice we get one ping packet out up here. The video is still running in the background, and now we're right back. Now there was a delay also in a second ping packet up to 338 milliseconds. But if we take a look down here, and I'll refresh the screen on this, you'll notice we have a fault-tolerant change again, but we're now running on host 178. Okay? And eventually it will rebuild the secondary VM on host 176. Now it takes a little while because you saw how long it took to do it initially when we enabled fault tolerance, and in essence it takes the same amount of time there to do it here. I'll click Acknowledge there. We'll do a quick refresh up here. Click back in the VM here. So now we have the continuous stream running. Let's see, we're seeing in our infrastructure that the host is officially registered as gone. Okay, you can see over here in the left window pane that we have the host physically down. If we refresh the screen over here, we should see the secondary VM is starting up, and it's starting up on host 176. So once we have that VM completely started up, we'll be back in a completely fault-tolerant solution on the remaining hosts in the cluster. And that, we'll give it one more refresh down here. You'll notice we had one more ping packet drop out up there, and that's typical when we are then back in a protected state. So eventually we'll see the information from the video being transmitted down here is still playing, will be shipped over from the fault tolerance logs for shipping purposes. And remember, to get your host into a state to be able to support this, you need to make sure that your networking is set up so that you have VM kernel adapters with at least one set up for vMotion. Okay. We've got one here for vMotion, we've got another one here for vMotion, and then another one for fault-tolerant logging, or FT logging. Okay, and it's best, obviously, to keep those separated, considering the amount of traffic that the fault-tolerant logging one has to ship over now. So, and here you can see some of the bandwidth usage. So that concludes our demo of fault-tolerant VMs with multiple vCPUs.